Hello everyone and welcome back to the Bodhi Academy. In today's PYQ series, we are doing the first chapter of 12th standard chemistry, that is solutions. So to begin with the first question, it reads that the vapor pressure of pure ethanol and methanol are 44.5 mm and 88.7 mm of mercury respectively. A solution is prepared by mixing 60 grams of ethanol and 40 grams of methanol. Calculate the vapor pressure of the solution. So in this question, we have to find the vapor pressure of the entire solution. Now the solution consists of two things. One is your ethanol that is present and the other one is your methanol. So to start with, let's look at the first step. First step is to find the molar mass of ethanol and methanol. So for that, with regards to ethanol, the molar mass equals to 2 into 12 plus 6 into 1 plus 1 into 16. All this 12, 6 and 16 are actually given down in the questions, that is their atomic masses are already noted down. So we have to only calculate their molar mass. So that comes to 46 grams per mole. Second, with regards to methanol, the molar mass is again 1 into 12 plus 4 into 1 plus 1 into 16, which comes down to 32 grams per mole. Now the next step is to find the number of moles that are present in this ethanol and methanol respectively. So first, with regards to ethanol, number of moles is given by given mass upon the molecular mass. Now the given mass is already given in the question, whereas the molar mass we have just found out. So given mass is 60 grams with regards to ethanol and molar mass is 46 grams per mole, which comes down to 1.304 moles. Same way with regards to methanol, it is given mass upon molar mass. Given mass is 40 grams and molar mass is 32 grams per mole, which comes to 1.25 moles. Now, to find the total moles that are present in the entire solution, we have to add both the number of moles of ethanol as well as methanol, and it comes to 2.554 moles. Moving to the step 3, we have to calculate the mole fraction that is given by X. Now first, the mole fraction of ethanol. How do we find mole fraction? It is given by the number of moles of ethanol upon the total number of moles that are present in the entire solution. So N ethanol we just found, it is 1.304 and total is 2.554. Moving down to methanol, it is N methanol upon N total, 1.25 upon 2.55, which comes down to 0.489. Now moving to the last step, that is to find the total vapor pressure of the solution. Now before we move that, we need to know the partial vapor pressures of both ethanol and methanol, okay? Because that is what, when we add, we end up having the total vapor pressure of a solution. So with regards to partial vapor pressure of ethanol, we find the product of mole fraction of ethanol into the partial vapor pressure of ethanol. So 0.510 into 44.5, that comes to 22.69. Same way we do it for methanol and we end up having 43.40. Moving to the last part, that is to find the total vapor pressure of the solution. We add the partial vapor pressures of ethanol plus of methanol, which is 22.69 plus 43.40, which comes to 66.09 mm Hg. Mm is millimeters of mercury. Moving to the second question, it reads that calculate the boiling point elevation for a solution prepared by adding 10 grams of CaCl2 to 200 grams of water, assuming that CaCl2 is completely dissociated. So in this question, there are some givens also, that is, we have the boiling point constant of water 0.512 Kelvin kg mole inverse. Molar mass of CaCl2 is given as 111 grams per mole. So to start with, Step 1 in this is to calculate the moles of CaCl2 that are present. Okay, so we know already number of moles is given mass upon molar mass. So given mass is we have 10 grams and molar mass is already given in the question, that is 111 grams per mole. So the total number of moles comes to 0.09009 moles. Moving to step number 2, we have to calculate the molality of the solution. Now when we talk about molality, it is number of moles of solute per kg of solvent. Now the problem over here is that the weight of water that is given, it is given in terms of grams. So we have to convert that mass into kgs. So here mass of water is 200 grams. Now if I want to convert it to kg, I simply divide it by 1000 over here. So I end up having 0.200 kg. So M will be equal to moles of CaCl2 upon kg of water. So that is 0.09009 divided by 0.200 kg, which comes down to 0.45045 moles per kg. Now another important thing over here is that we need to determine the Van Hoff factor that is given by I. Now if you look at CaCl2, because the question reads that CaCl2 has completely dissociated, so it has broken down into its respective ions. So if we see, there is Ca2 plus which is present, that is there is only one Ca2 plus, whereas the chlorines that are there are two of them. So total number of ions that CaCl2 dissociates into is 3. Hence the Van Hoff factor, that is I, comes down to 3. Now moving last to calculate the boiling point elevation of the solution. It is given by delta T B equals to I, that is Van Hoff factor, into Kb, that is my boiling point constant, into M, that is my molality. So 3 into 0.512 Kelvin kg per mole into 0.45045 moles per kg, and it comes down to 0.692 Kelvin. So my boiling point elevation of CaCl2 for this particular problem is 0.692 Kelvin. Moving to the third question. If 3 grams of glucose having molecular weight 180 is dissolved in 60 grams of water at 15 degrees Celsius, what will be the osmotic pressure of this solution? So in this problem, we have to find the osmotic pressure of the solution. Osmotic pressure is given by pi. Okay. So starting with step 1, we need to calculate the moles of glucose and the volume of the solution for this particular mixture that is given. So for number of moles of glucose, we know formula given mass upon molar mass. So which comes to 3 grams upon 180 grams per mole, which is equal to 0.01667 moles. Now moving to the volume of the solution that is present. Since the mass of water is 60 grams, we assume that the density over here is approximately 1 grams per mole. Now volume, if we have to find density, then it is mass by volume. So over here also, you to find volume, it is density into mass. So volume of solution, we consider it to be equal to volume of water that is present, which is 60 ml. If I convert it to liters by dividing it by 1000, it comes to 0.060 liters. Moving to step 2, calculate the molarity of the solution. Now over here molarity is given by C, capital C. So it comes to number of moles of glucose upon the volume of the solution. So which is 0.01667 moles divided by 0.060 liters, and the answer comes to 0.2778 moles per liter. Now the next part is we have to convert the temperature. So over here temperature is given to us in degrees Celsius. Now our aim is to convert it into its standardized form, that is to Kelvin. So for that we add to 15 degrees Celsius, we simply have to add 273.15 Kelvin, and it comes down to 288.15 Kelvin. Now finally moving to the osmotic pressure, the formula is given by pi equals to ICRT. Now for this problem, I, that is my Van Hoff factor, is known to be 1. C, that is my molarity, we have received to be 0.2778 moles per liter into R and temperature, that is already calculated over here. R is the gas constant and temperature. So that product is already multiplied and we have the value 0.0821, and finally we end up having the osmotic pressure of this solution to be 6.57 atmosphere. Moving to question number 4. A solution of an organic compound is prepared by dissolving 34.2 grams of it in 500 grams of water. The boiling point of solution is obtained to be 100.104 degrees Celsius. Calculate the molecular mass of the organic compound. Given Kb for water is 0.52 Kelvin mole inverse. Okay, so in this question we have to basically find the molecular mass of the organic compound. They have not actually told us what exactly is the molecular compound, so we have to go in a reverse direction using the boiling point elevation formula to find the molecular mass of whatever organic compound is present in this solution. So to begin with, we start by taking the boiling point elevation formula, that is delta Tb. Now over here delta Tb, we know it is basically a difference. Delta is given, so there is some kind of difference in temperature that is happening. So that difference is given by delta Tb equals to boiling point of the solution minus the boiling point of water that is present. So here boiling point of solution is 100.104 degrees Celsius and boiling point of water we already know that it is 100 degree Celsius. So which comes down to 0.104 degree Celsius. So from boiling point elevation we have found the actual value of delta Tb. Now moving to step number 2, use the formula for boiling point elevation. Okay, so over here we know now delta Tb is given by the actual formula is Kb into m. M over here is my molality that is given. So molality is given by moles of solute upon mass of solvent in kg. So moles of solute in the question they have said that it is 500 upon mass of solvent in kg is 1000. So we end up having a molality to be 0.5 kgs. So using this molality, now I go back to my formula of delta Tb equals to Kb dot m. So from here if I substitute, I can end up having my molality that comes down to 0.2 moles per kg. Okay. Now moving to step number 3, calculate the molecular mass of the compound. Now over here we use molality formula. So m equals to moles of solute upon kg of solvent. M over here is 0.2 moles per kg. Moles of solute, if we have to find, it is 0.2 into 0.5 which gives 0.1 moles. So molecular mass if I have to find, then my formula goes as mass of solute upon moles of solute that are present. Now the mass of the solute was already given to us in the question, which read as 34.2 grams, and moles of solute we just found is 0.1 moles. So finally we end up having the molecular mass of the organic compound, which is 342 grams per mole. Moving to the next question. A solution containing 1.02 grams of glycerin per 100 ml of solution is found to be isotonic with 2% solution of glucose having molecular mass 180 grams per mole. Calculate the molecular mass of glycerin. Okay, so in this case you have to find the molecular mass of glycerin that is there. So there is basically a solution that is present. In that there are two things. One is there is a glucose solution as well as there is a glycerin solution that is added. From that we have to only find the molecular mass of glycerin. So to begin with, we start by calculating the molarity of the glucose solution. So now in this question something very important is given. It reads that it is a isotonic solution. Now isotonic when we hear, in that case we should know that the osmotic pressure, that is pi, is same for both of the solutions. So may it be my glycerin solution or may it be my glucose solution. Both of them are going to have osmotic pressure that is going to be equal. So pi equals to ICRT. Since glycerin and glucose are non-electrolytes, the Van 't Hoff factor I is 1 for both of them. Non-electrolytes is in, they are not going to basically dissociate into their respective ions. So in that case, we consider the I value to be 1 over here. Therefore, the molar concentrations of both must also be equal. That is my C that is given. So, C of glycerin will be equal to C of glucose. So, glucose solution is said to be 2% solution. Okay. So, 2% solution meaning it is 2 grams of glucose present in 100 ml of solution. So if I try to find the number of moles of glucose, it is given mass upon molecular mass, that is 2 upon 180 grams per mole, which comes down to 0.0111 moles. Now volume of the solution we assume over here is 100 ml, that is 0.1 liters. To find molarity of glucose, it is given by moles of solute upon volume of solution. So moles of solute we just found is 0.0111 upon 0.1 liters, which comes down to 0.111 moles. So since both are isotonic and non-electrolyte type of solutions that are present, so over here the value, that is molarity of glucose that I found, is going to be equal to molarity of glycerin that is present. So molarity of glucose as well as molarity of glycerin over here will be 0.111. Now moving to step number 2, we have to find the molar mass of glycerin. So molarity is given by moles of glycerin upon volume of solution. So over here we do not know the moles of glycerin, but instead we have already found the molarity. So molarity is 0.111 equals to moles of glycerin upon 0.1. So when we multiply 0.111 into 1, we end up having 0.011 moles. Okay, so that gives me the moles of glycerin that are present. Now I can easily use the molar mass formula, which is mass of glycerin upon the moles of glycerin that are present. So mass of glycerin in the question is given to be 1.02 grams and moles we have just found is 0.0111, which comes down to approximately 92 grams per mole. So that is the molar mass of glycerin. Now moving to the next question, we have a MCQ that is present which asks us, in how many ways can the concentration of a solution be expressed? And the options given are 1, 3, 5 or 8. So we'll start by jotting down what are the different ways in which we can define the concentration of any given solution. Okay. So to start by, first we have mass percentage. Okay, so that is one. Then opposite of mass is with regards to your volume. So we have volume percentage. Then we can even define it by parts per million, that is my ppm, parts per million. Okay, after this we can even give it by mass of volume, mass by volume percentage, mass by volume percentage. Then we have our normal terms, that is molality, and also normality. Okay, apart from this we can have a few more, that is we can have our mole fraction also. Okay, so mole fraction is the last one. So now let's see how many are there. Mass percentage 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 different ways by which I can find the or express my concentration of the solution. So in this case my answer is D, 8. Now so far in this chapter we have only solved major problems that are asked. So this chapter is mostly based on all the problems that are covered. Okay, so most of the important problems we have already covered till now in this video. So now I'll tell you some of the subtopics with regards to the theory part which is related of this chapter. Okay, what are the most probable topics from which questions can be asked. So over here, first one is the graph representing ideal and non-ideal solutions. Now this is a very important part wherein they ask you, they give you different solutions which are with regards to examples that are given, and you have to identify which of them is going to be ideal guess one, which is the one that is going to be a non-ideal one. So with regards to that, then you all have to draw the graph. Okay. Second one, this is very important, positive and negative deviation graphs. Okay. Multiple times, multiple years questions have been asked on the positive and negative deviation graph. So this has to be completely thorough. Okay. Moving to the third one, we have the freezing point graphs. This was not majorly asked, but maybe in 1 or 2 consecutive years it was asked. Next we have the colligative properties. From this mostly questions are asked, but at times somewhere here and there where there are a set of questions of 3 and all, then for 1 mark and all they might ask you like what is the definition or what is the equation for boiling point elevation, then freezing point depression, relative lowering of vapor pressure and osmotic pressure. Next, we need to know some of the very important definitions with regards to this lesson. Apart from your molarity, normality, solute, solvent, all of this, apart from this, we also need to know what are ideal solutions and what are non-ideal solutions. Also, what is vapor pressure, what is partial vapor pressure, total vapor pressure of a solution, all of these things should be known. Now this, with regards to vapor pressure, this is not only important with regards to your theory, but even while solving your questions, which are like the problem ones, in that also you'll need to know what is the vapor pressure, how to find vapor pressure, how to find partial vapor pressure, and then what is the total vapor pressure. Last two, we need to know these very two important laws, that is the Raoult's law and the Henry's law. So if you all can cover up these many subtopics of this chapter, I feel it is going to be more than enough. Apart from this, the problems we have already solved. So thank you so much for watching today's video. I hope you all have understood. If you all have any doubts or anything, you all can drop them down into the comment section. And please don't forget to like, share and subscribe to the Bodhi Academy.